Hello and welcome to the June 1st podcast. My name's Ethan Moriarty, and whether you've been here since day one or this is your first time listening, I want to thank you very much for tuning in. Real quick, I want to point you in a couple directions where you can find some of our socials. Our primary place is our YouTube channel, June 1st, spelt out just like the show, so not one ST, but FIRST. And you can find videos of weather that we've documented and engineering work pertaining to weather research. Also, you can find me on Twitter at eMoriartyWX. And if you wouldn't mind rating the show, Spotify recently introduced a rating feature on the star system. So if you like the show, please give us 5 stars, or on any other app that you're on, please give us a nice review if you're able to. It means a lot. And now, on to our incredible show. Jack Sillin is a senior at Cornell University majoring in atmospheric science, hailing from the great state of Maine. He's been writing about the weather since 2011 and has built his skills in forecasting, communication, and programming. Jack, welcome aboard.
Thanks for having me.
I'd have to start off this podcast by asking you about the latest blizzard, January 29th in southeastern Massachusetts. And how was that experience for you? And did the Cape Cod experience live up to your expectation?
Yeah, it was a great storm to get to be in. Really lucky that we were able to make the trip out there for that. It was really fun. We got to sort of sample every bit of the storm's impacts, from storm surge flooding in Sandwich, Massachusetts, to heavy bands of snow over 2 inches an hour, and then extreme wind gusts. Well, maybe not extreme by hurricane standards, but we got up to 65 miles an hour at 1 meter above the ground, which is pretty good. You couldn't stand up much more than a meter, even those of us that get closer to 2. But the 10-meter stations measured some hurricane force wind gusts, which were pretty fun to get to walk around in.
Yeah, I got to experience it from southeastern Connecticut, which, saw some pretty heavy snow totals across, like Mystic, New London areas. And I wanted to go to eastern Massachusetts, but unfortunately I had some prior commitments in Connecticut. So I kind of had to commit closer to home because I couldn't risk getting too stranded. But one of the things of note that maybe is, maybe some controversial topic is the infamous photo of the hot dog. Care to explain the questionable condiment of choice? And do you defend your action?
Well, life lesson learned. You're probably better off spending half an hour the day before a snowstorm going to the grocery store than you are looking at the latest run of the Her. I got distracted, forgot ketchup. I wasn't just going to eat a hot dog in a bun. So we had some mayonnaise. I'll tell you, it wasn't, best hot dog I've ever had, but we survived. Learn from it. I was amused by everybody. It caused quite a stir on Twitter. I joke that this is probably my most influential idea of the year, if not the decade. So it's all downhill from here, folks.
Yeah. I thought like the uproar was kind of unfounded. I didn't realize that was such a preposterous idea, but clearly other people think otherwise. I think it was funny though. I forget which company it was, but you had official mayo manufacturers actually kind of endorsing the hot dog incident, if we want to call it that. So
Twitter's a weird place. You never know what you're gonna find.
Oh yeah, for sure. And as it stands right now, we're looking at more another blizzard, I should say, not an opportunity, on the evening of what am I trying to say here? As of tonight, February 1st, we're looking at another winter storm event. Different style, not a nor'easter, more of a clipper style scenario. What do you see in the impact of this storm, and what about this storm can you say may be of great concern for different parts of the United States?
Yeah, so this is an interesting setup. It's a classic overrunning. We got rich subtropical moisture moving up and over the shallow but very cold Arctic air mass sliding in from Canada. I really don't think this is going to be as much of a blizzard concern. We just don't quite have the overlap of intense winds and really intense snow to worry as much about that. But I think that the story here is really going to be the mixed precipitation. So anytime you have this shallow Arctic air mass, you can get a little bit of warm air aloft as the cold air is not quite as quick to move in a few thousand feet above the ground. That creates the opportunity for mixed precipitation. Now, if that falls as sleet, it causes some slippery travel, but maybe some disappointed snow lovers. But really, the impacts there are not that severe. The concern is really if we get that to fall as freezing rain, and that can cause impacts to trees and power lines. We'll see how extensive the freezing rain can be. I mean, some of the earlier guidance was a bit more bullish on multiple waves of low pressure traversing this front and producing freezing rain in the same areas. And the latest guidance seems to have backed off of that a little bit. So more folks might experience slippery travel, but fewer people might be at risk for devastating power outages, which would obviously be good news. So I think that's really going to be the mixed precipitation to watch here, especially southern central Mississippi Valley up across the Ohio Valley is really going to be the best spot for that. And then behind the storm, cold air pouring into Texas. Obviously, that's not a good combo. This is nothing like what we saw last year, but forecasts show that the grid could be under some strain come Thursday and Friday. So definitely watch out for that as well.
Yeah, I think, some of the ice storm concerns that have taken place, are definitely founded. It's nice to see that guidance has kind of shied away from that. I mean, some of the notable ice storms that I can think of in Quebec in the 90s, if I'm not mistaken, was one of the great, ice storms that had, crippling power grid consequences for an entire Canadian province. So it's definitely always a major concern. I always get more concerned about icing events more than, large snow total events in terms of actual, infrastructure impact.
Yeah, and no leaving Maine out when you bring up the ice storm in 98 with a Mainer on your podcast. That one was huge in interior parts of Maine, over in New Hampshire, Vermont, and New York as well. But the other sort of variable is we're starting to leave the climatological peak of ice storm season. Anytime the sun starts to get a little bit more juice to it, once we're moving into the month of February, as we're recording this today, makes it just that much harder for the freezing rain to cling as efficiently. So that's not to say that we will escape this with no problems, but the clock is starting to run out on devastating ice storm potential for 2021, 2022, which is always good to see.
So I want to rewind the clock a little bit and kind of get into a little bit of your past. What would you say is your catalyst for getting into weather? Was it, a specific event that was a light switch moment, if you will, or was it more the general fascination from, prolonged exposure, if you will, hailing from an interesting area that is southern Maine?
Yeah, so I always say that there are two things that got me into the weather. The first was the Patriots Day nor'easter, as we call it, up in Maine of April 2007. That brought significant rain and wind to my little town of Yarmouth, including some major trees that fell down right around our house. So that was a pretty memorable display of Mother Nature's power at a young age. And then flying cross country to visit relatives in California, my mom decided the news was too scary for a kid and cartoons were garbage. So the Weather Channel was the only thing that Jack could watch on the in-flight TVs. So, 25 plus hours of Jim Cantori later, I decided this was a pretty neat thing. And so I started to learn more and more about it, and the rest is history.
Yeah. I mean, I feel like in terms of my story, at least, it was, kind of I've always had that fascination for weather. And then I had the June 1st, 2011 tornado to kind of, kick that love into overdrive. So I feel as though that there's always somewhat that fascination there for us weather lovers, and even the prolonged exposure may not necessarily be enough. So those big events can always kind of influence the future of our career paths, I guess you could call it.
Absolutely.
Getting a little bit of your background a bit, you started writing about the weather way back in 2011, which is going on 11 years ago now. So I want to ask, where did the motivation for that start? Most of us, when we're a younger age, we don't often, want to have maybe more homework, if you will, but obviously passion can kind of drive us to, explore these different passions that we have. So where did the motivation to start writing about your local weather kind of first originate?
Well, the motivation came from my dad, really, who decided to assign me extra homework of writing about the weather for our friends and family. Honestly, the blog started sort of as a shortcut in the days leading up to the Halloween 2011 nor'easter. Friends and family from around New England were emailing, asking, what their grandson, niece, nephew was thinking about the storm. And rather than writing emails back to aunt, uncle, granddad, whoever else, I decided to make a website and I could send them the link and then I would only have to write it down once. So it was actually, a little bit of laziness there on my part. And then my dad kept bugging me after the storm departed to, keep writing about the weather, even when there wasn't a historic snowstorm in the forecast. It actually took a couple of years before I really came around to that. But by the time we started moving into, especially after Hurricane Sandy, I got really into doing forecasts every day. And thankfully, up in northern New England, you don't really get that much time between interesting weather events, even if you don't get a historic snowstorm or extratropical cyclone every day.
Yeah, that's for sure. I mean, the 2011 October snowstorm, as you will, was another one of those storms that definitely impacted my life, especially being later that year for me, at least. And so I was very hyper focused on the weather during that time. I don't remember the impacts in Maine, if it was as severe it was in southern New England. Was it just more of a typical snowfall event, if you will? I mean, there was still the, heavy, wet precipitation, but I imagine at that point up there too, Maine loses most of its foliage, which is another concern when it comes to those earlier snowfall events.
Yeah, my memories of this, what was I, 10 years old at the time, aren't quite the sharpest. But I don't remember there being as big of an impact up here. Actually, we were able to overcome the sort of warm surface temperatures with extraordinary DGZ dynamics. We didn't actually get the sort of cement or as much of the cement snow as Massachusetts got. We actually did get our ratios up and over 12-1, even along the coast, even with temps near freezing, because the dendritic growth was just so prolific aloft. I'm sure there were power outages. I'm sure there were problems. I sort of remember it being a little bit of a disappointment. My house was forecast for 8 to 12 inches by the Weather Service, and I think we picked up 4 or 5. So that was a little sad for me, but in general, I don't think it was nearly as big of a deal for us as it was down the coast.
Yeah, I remember I was at my good friend's house for a birthday sleepover, and I was trapped at his house for a couple days because of all the trees that ended up blocking the roads. But he lived up on top of a hill, and where he lived, you could normally during the daytime you could see the Springfield skyline in western Massachusetts, but that night, obviously the night was just lit up with transformers blowing in the distance. So we were sitting up there watching, different areas of the Springfield skyline start going dark as these transformers blew, which was a very another surreal moment with trees cracking all around you. So it's amazing just how prolific that storm was looking back on it 10 years later.
Absolutely. That was an exceptional event. Hopefully we don't have to deal with that kind of impact to the power grid anytime soon.
Yeah, for sure. As you moved along in your young weather career, if we want to call it that, where did you start to develop, forecasting skills for yourself, and what are some of the primary resources that you started to dig into to kind of start to build that skill set?
Well, my first guidebook was the area forecast discussion issued by the Weather Service up in Gray, Maine. I read that every day, twice a day, or more often if they would update it more often. That was really something. I still read those almost every day, twice a day, if I'm at all nearby. it's a great insight into what's going through the minds of some of the best forecasters in your area. And to all you weather service forecasters who might be listening, thank you for writing the long AFDs that explain in great detail what you're thinking. If I want just the number of what your high temperature forecast is, I can go to the normal page where you display that for me. So for everybody who gets into the detailed dynamics, thank you. You helped teach me a lot. After that, I took my sort of deeper questions to the UCAR's COMET program. They have modules ranging from sort of basic, what are winter precip types, to what are the microphysical processes that produce those precip types, and what does each term of the quasi-geostrophic omega equation mean? So I was trying to decipher that all in the middle school and high school. I'd be lying if I say I picked up every one of those nuances, but it was a great introduction before there was a class I could take. So yes, huge shout out and recommendation for the UCAR COMET program. That was very helpful.
Awesome. Now, some of your more recent work involves Python, and I'm not going to lie to you, I'm an engineering guy. I developed my coding skills on MATLAB. You're probably going to judge me for that. So
shameful, really.
Take it with a grain of salt. But I absolutely love your SKU-T plots overlaid onto maps with the atmospheric model runs, kind of taking a little bit of inspiration from Cameron Nixon's hodograph plots. When did you start incorporating the Python side and the coding side into, I guess you could say, your skill set?
Well, I would say I tried a lot early in college, even late in high school. I tried over and over again to get into programming. I just couldn't do it. It was complicated. It was like learning another language, which I also did terribly at in high school. So I tried. I took classes at Cornell, both a sort of introduction to programming for meteorology majors, which I not barely made through, but made through with, not quite the standards that I would normally give myself for academic work. I tried short courses. I tried workshops with Unidata. None of it really stuck for me until March of 2020, when I was sent off to my girlfriend's house up in really rural Maine. And stuck there for 3 weeks with mostly nothing to do before classes started back up again. I was like, all right, well, I'm gonna lock myself in this this desolate region, and I have enough of an internet connection to get some NetCDF files, and so I'm gonna actually just learn how to do this, because if not now, when? And maybe this can be a silver lining to come out of the horrible COVID situation. And so that actually worked for me. I started with the Unidata MetPy example scripts, and I just tweaked things one by one to get plots that were, step by step, a little different, a little more unique, asking questions of people on Twitter, Stack Exchange, so on. It really took a few weeks of very, very, very concerted effort in March of 2020 before I could actually get off the ground with Python.
Awesome. So I think you may have already answered kind of this next question a bit, but someone that's looking to kind of maybe expand, that Python or, some other coding language side of their skill set, because as you know, atmospheric science meteorology is becoming more and more of a almost computer science based science, if you will. Given how reliant we are making computer atmospheric models as a part of our forecasting techniques. So maybe, is there, other than just necessarily brute force, kind of forcing yourself to learn it, what advice would you give to someone that wants to kind of maybe get an early jump on it to figure it out?
I would say figure out what motivates you, and make sure you're always doing something that's interesting to you. I was not sufficiently motivated by hello world and this is what an array is and this is what a list is and so on. So I don't have the attention span for that. I always got bored and sort of tuned out before I could get anywhere with classes that were taught like that. Not now, some people are motivated by a deep understanding of the fundamentals of a given topic. And for them, that approach is great. And obviously you need to learn those fundamentals at some point. For me, what motivated me was making pretty maps. So if I could start making pretty maps and knowing nothing, which thankfully you can do now, you have Unidata's MetPy examples. You can, copy and paste that into a file and run it and you're done. You have a pretty map. That was motivating to me. And then you can start changing the colors, and then you can start changing the contour levels and the parameters. And along that journey, you will pick up the fundamentals of data types and, data structures and so on and so forth. So do something that motivates you, whatever that may be, and you will pick up what you need to know about the programming along the way. At least that's what worked for me. Obviously, everybody's different.
Yeah, that's for sure. That's what ended up kind of being my approach, I guess you could say, towards MATLAB, because I do a lot of data visualization with it. As you know, even though I'm very biased in my MATLAB roots, I mean, I also do C++, but I got to eventually try to branch into the Python world of things, because it's just so amazing just how versatile it is given the amount of, kind of material there is out there for it.
Virtual and open source. I mean, this is
exactly.
what the thing that kills me about MATLAB. I'm not paying for a site license when people develop open source software, and nobody should have to. That's a great way to exclude a lot of smart people who just don't have the money to buy site licenses. So screw you, MATLAB, and everybody move to Python. That's my soapbox for today.
Yeah, I think that's going to be me in the coming days as my MATLAB license expires from school. So yeah, I think I have to.
Good luck.
Let
me know if you have questions.
Yeah, will do. We already talked about it a couple of times, but you come from Maine, and Maine is personally one of my all-time favorite states that I've gotten the chance to visit. I've been to Acadia National Park multiple times. I love it up there. I've hiked Katahdin once, and just such an amazing state. I know you're an avid lover at the outdoors, so I got to ask, what do you love most about your home state from either a weather perspective or, something more traditional like geography or something like that?
Yeah, I would say I love, this is a classic sort of antisocial nerd answer. I love the wide open, far northern woods where you can drive for dozens or hundreds of miles on a dirt road into the middle of nowhere and see more moose than people. You just don't get that kind of wilderness experience very many places in the U.S. anymore. And it's one of the last places I think you can really feel isolated from the outside world. And I think that, everybody at some point feels that urge to be sort of just immersed in the outdoors and in nature. And there are huge swaths of land up in northern Maine where you can spread out and do that. I also love the mountains, so we got plenty of those. And yeah, I would say that's my favorite. I mean, the ocean is obviously really nice, especially in the summer when it gets really hot inland. It's nice to be able to turn on nature's air conditioner. But for me, I love the North Woods, and I really have enjoyed exploring up there. There's a lot to see.
Yeah, the famous 100 miles of wilderness on the last part of the AT. That's maybe a bucket list item for me that I want to do.
I've done it. It's great. You should totally do it.
Yeah, I think I'm going to get to it at some point in time. Hopefully maybe this summer if things are looking pretty quiet.
There you go. Yeah, it's a beautiful, beautiful place.
Yeah. Awesome. So I want to ask a little bit about your experience at Cornell. I've talked to your good friend and fellow Big Red, I can't say alumni yet, but Jack Fierstein. What do you love about Cornell, and what would you maybe give in terms of maybe a pitch for a prospective student that's looking to maybe study atmospheric science or meteorology at Cornell?
Yeah, so my favorite part of going to Cornell, I think, well, there are two parts. One, you're just surrounded by a lot of smart people. That has nothing necessarily to do with the weather. But everybody who ends up at Cornell is really smart about something. And there's always somebody there, no matter how good you think you are at something. There's always somebody there who can do it better than you. Now, some people get really intimidated by that, but I really have enjoyed it because I feel like I can learn as much from my peers as I can from my professors. And that has been a really rewarding experience for me personally and intellectually. So, yeah, that's been really fun. And you get to do lots of, cool and quirky things that, you can't do at a lot of places. I mean, I took a wine tasting class, last semester, which was really interesting. Yes, we did taste wine in class. But that was only one of the aspects of it that I really enjoyed. As with regards to the meteorology program, it's great because it's small. I mean, you're not, a nameless, faceless blob in the back of the classroom. You really get to know your professors. You work with them on a first name basis, most of them. You don't feel like you're cut off from the faculty because you're not a grad student or whatever. And that has been really fun. And the other thing about that is you get to really leave the program better than you found it, which is something I've really tried to do. I've worked on curriculum changes, developing new courses, interviewing potential new faculty hires. I mean, all these kinds of things that, obviously I'm not the only person in those rooms, but I get a seat at the table as a student, which is not something that you can say everywhere. And so it's been really rewarding for me to be able to take part in some of those conversations, get a better understanding of, how to shape organizational culture for good. Those are the kinds of things that are you can only learn if you're participating in that. And I think you can really, maybe you can't only participate in it at a place like Cornell, but having a small and flexible and dynamic department certainly helps.
Yeah, I resonate with that quite well. I went to maybe a school that's not traditionally known for engineering, because when I was touring schools and stuff, I went to a lot of the big name engineering schools, and it didn't feel as though that faceless aspect that you mentioned. You're kind of in a giant lecture room of 100 some odd students, where I ended up going to Quinnipiac University. My graduating class in mechanical engineering was 28. So, we were a tight-knit class. We had, 4 professors of mechanical engineering, and, you get to know them all pretty well. And, the fact that you can just go into their office and kind of even just pitch ideas, you don't have this intimidation factor, I guess you could say. And I wouldn't have been able to do my engineering research or my weather research with the engineering focus that I was able to do if it weren't, for this very tight-knit nature that we had. Because, I feel like you could be easily dismissed at, a larger university or a large program or something along the lines of that. So I think it's really important to have, relationships like that with, faculty that are, yes, your mentors in that sense, but are also willing to kind of break things down and allow you to kind of, teach them something, I guess you could say, because none of my professors knew anything about meteorology. So I had to be kind of a subject matter expert in that and kind of guide them along on how to make a research project that's engineering based, but for a meteorological context. So I resonate with that small program quite well with you.
Yeah, it's been really great fun to be both learning and teaching. One of the cooler intellectual experiences I've had really was, teaching. I guess my differential equations professor, world-renowned mathematician, super duper duper smart guy. I would go to his office hours, and it was a 500-person class, but almost nobody went to his office hours. I don't know if the schedule was bad or if they were intimidated or whatever, but that was the only one that worked for me. So I went up and, sheepishly asked my 2 or 3 questions about that week's homework. And then, we would get going for, over an hour on meteorology and complex systems and chaos theory and all that sort of stuff. And that's it's really special to have those experiences. And again, I don't think you can't get them at bigger places or in bigger contexts. I just think that the sort of skills are tipped a little bit towards that in a smaller setting.
I shouldn't be the one to rag on those larger institutions, I guess you could say. But for me, I know I functioned a lot better in a small classroom environment and having a lot more personal connections with, my faculty members. It makes it easier for me to learn, at least. And I know a lot of other people kind of serve in that way. So, and plus too, you get to know your classmates really well and kind of form these, pretty special relationships, study groups and stuff like that to ultimately kind of advance everyone's, well-being, I guess you could say, in a sometimes stressful environment.
For sure.
All right. Do you have a favorite weather memory, whether it be something that you've personally experienced or maybe something along the lines of maybe a tough forecast that you've pulled off that, really sticks out in your mind and is a moment that's proud for you? I mean, maybe those are 2 different questions, but or 2 moments that you have. So I'd like to hear what you have to say about that.
Yeah, I think the first one that probably comes to my mind is from March of 2018. We had these 3 major nor'easters in quick succession, each of them sort of a unique forecasting challenge. I was lucky enough that was my spring break in high school, those 2 weeks. And boy, was that perfectly timed. So the first storm, I was lucky enough to be up at Sugarloaf Ski Mountain up in northern Maine. Midweek powder day, 2 feet of snow, absolutely nobody except me and a few locals who were retired up on the mountain. That was really special. And then headed out of there, back down to Yarmouth. And then my dad and I were heading out to Cornell to go visit. This was my senior spring. And while we were sort of driving out, I was looking at the latest guidance, and I was, the GFS model had this next wave sort of sliding out to sea, and the Euro had it amplifying coming up the coast as another major nor'easter. So I went up into the 500 millibar layer, looked at the vorticity. It was sort of up over northern Canada. And it was clear that the key variable here for why was the Euro and the GFS treating the system differently was a sort of angle of approach of this northern stream disturbance, and whether it would slide more east towards Hudson Bay before dropping south, as the GFS would indicate, or whether it would drop south over sort of Alberta, Manitoba, Saskatchewan. And so I went over into the water vapor, and sure enough, this was losing a lot of latitude quickly over Western Canada. And so I was like, all right, Dad, we got to go back to Sugarloaf. So I canceled some of my meetings. Actually, I had some tour or something. I had called one of my friends who went to Cornell and was like, look, I can't be here for the tour tomorrow morning. Can you just show me around? And so he said yes. And so I felt like I took care of business in Ithaca, and then we drove all night through Quebec, which is the fastest way between South Central New York and northern Maine. And we made it back in time for the first flakes of another 2-foot snowstorm, which I also got to ski midweek. So that was pretty fun. It was a good forecast. I thought a pretty clever forecast, and it ended up resulting in another amazing day of skiing. So that was pretty great.
That's awesome. I mean, I can't beat those powder days, and Sugarloaf is one of the best Northeast mountains in my opinion. So I haven't gotten up there too much recently, but man, it's a treat every time I go up there.
Yeah, I love it. Again, that wide open North Maine woods, and nothing better.
Yeah, so you're just making me want to, kind of drop off the grid and just move up to northern Maine. Uh,
Highly recommend. I've done it for a week or two at a time. Pretty fun.
um, Another thing I want to ask about is tropical forecasting. We've had a lot of blizzard talk. When did that start to come into play? And was it something that you maybe always had a passion for, or was it something that kind of, came a little bit later?
Yeah. So my first interaction with tropical meteorology, well, was 2008. Tropical storm Hannah moved up the coast in, I think it was August of '08. And the local TV weatherman, Charlie Lopresti, WGME 13, called for 5 inches of rain. And so my dad and I decided to hold him to it. We built a little rain gauge out of a water bottle and a funnel and put it outside on the back deck. And the next morning, sure enough, 5 inches of rain. And I was sort of amazed that anybody could have predicted that. It was a lot of rain, especially for Maine. And then I remember watching Hurricane Ike move on shore in Texas on TV, and I thought that was really interesting. So 2009, I studied up on my tropical meteorology. I bookmarked the Hurricane Center website. I refreshed the tropical weather outlook at 2 and 8 o'clock. And of course, 2009, absolutely nothing happened in the tropical Atlantic. So I decided tropical meteorology was boring. And that was that. I didn't really get back into it until 2017 when I started working for this Swiss company, weather.us, and this was a nationally focused entity. So they wanted me to forecast all over the place. And so then I got sort of dragged into this tropical stuff because I had to forecast for Harvey, and that was the big story. And so they wanted me to write blogs about Harvey and tweet about Harvey. And so, all right, fine. Back to the tropics we go. Fine. It's not my natural habitat. I'm a cold weather guy. I hate the humidity, but tropical meteorology turns out it's really interesting. It took me a lot of learning to understand sort of the dynamics and what the key variables were. I've been in a baroclinic state of mind my whole life. And so switching over to barotropic was a little bit of a culture shock, one might say, but it was really interesting. High stakes. I mean, there's nothing high, as much as I love blizzards, and I do love blizzards or tornadoes, there is nothing higher stakes than a hurricane. You can't get that much property damage, destruction, impact to society over such a wide area. Hurricane is Mother Nature's most dangerous and disruptive force. So that sort of brought me a little bit more attention nationally, forecasting for the hurricanes of 2017. And then the people kept demanding hurricane forecasts, on Twitter and stuff. So then I sort of became the hurricane guy, which was strange to me growing up in Maine. But sometimes you gotta take advantage of what life gives you, and if there's an opportunity to branch out into a different area of the field, you take that and you make the best of it, and you see what happens. And for me, it's ended up working out pretty well now. People all over the place are sort of write in and ask what I think about the hurricane, and never would have seen that coming a few years ago.
Yeah, that's I imagine a pretty, like you said, kind of a shell shock type of experience. Like you said, hailing from Maine. Now that got me thinking, like, out of coming from the blizzard side of things and then adding the tropics. You mentioned tornadoes, mesoscale severe weather. Is there, a particular avenue that you see yourself in now? That this is the, is blizzards still my favorite thing, or you kind of enjoy doing the tropics now, or do you even, branch out even further and say that maybe mesoscale meteorology is something that you find yourself kind of involved in the future, or is it kind of just maybe a combination of the three?
Yeah, I mean, it's sort of hard to say. I always like to say, whenever opportunities will present themselves, I'll sort of see where the wind takes me. That being said, I really fell in love with convective modeling. Last semester, I took this class on numerical weather models, and part of the class was you got to run some WRF simulations on the Cheyenne supercomputer out in Wyoming. And perplexing me, I don't understand why this was the case, but nobody else in the class seemed all that interested in pushing this computer to its limits. But of course, when I see myself granted access to one of the biggest supercomputers in the world, I want to go play. So halfway through the semester or so, I asked the professor, look, if nobody else is going to use our allocation, can I just have fun?
Yeah.
And he's like, yeah, do whatever you want, man. If you manage to burn through our allocation, I'll write them an email and get you more. And so I was like, all right, well, challenge accepted. And I really went off the rails there. I did 300-meter supercell simulations. At that resolution, you can resolve not just the storm as an entity, but you can resolve storm scale features, the forward flank gust front, the rear flank gust front. You can resolve a tornado. I did some of my simulations did explicitly resolve tornadic vortices, which was incredible to me. I mean, I'm a huge fan of Lee Orff and his work, and obviously I didn't get down to 10 meters.
Yeah,
as hard as I did try. Turns out you do actually need the custom IO drivers that he spent a decade making to get that. But anyways, I really fell in love with that. So that's something that I probably want to pursue in grad school. It's the thing that sort of singularly captures my imagination more than anything else. As much as I love covering hurricanes and standing outside in blizzards, I sort of wake up every day, even in the winter, thinking and scheming about how I might be able to get myself back onto a supercomputer to do more of those simulations. So that's probably where I'll start wandering towards in the near future.
So that kind of tails into one of my other questions was, where do you see yourself, come graduation? It's coming up awfully fast. I know exactly the shoes you're in right now, because I graduated in 2021. So it's like, I know exactly where you're at right now. Where do you see yourself? Is it, you teased grad school. Do you see that, kind of being your future?
So right after graduation, I'm going to take a year off with my girlfriend. We're going to go traveling. She's at med school. And so that will sort of occupy her future for the coming decade. So, we're going to take a little time off, go be young and free while we still can. I'm still going to keep a toe or two in the forecasting and development game next year, doing some remote work, but that's really more to, keep the food on the table and gas in the van. And then after that, I'm probably going to go to grad school. She's off at med school. Hopefully doing something with convective modeling, but we'll see what happens there.
Yeah, exactly. Good for you though. It's, I wish I took a little bit more of a break myself. But that's what life kind of throws at you sometimes. I had a good job opportunity, so, can't turn those kind of things down. Yeah, and my girlfriend, she ended up going straight into grad school 2 weeks after graduation. So it's not like she's OT. So it's like she had straight changeover. So, but that's really exciting. And, when you were coming out with those results, it was really fascinating to kind of see even just the imagery associated with it and, getting those storm scale features. And it's amazing what can even be done at 300-meter resolution, because when you think about it in your head, like 300 meters sounds like a lot, but supercells are a lot larger than, people really think, because, it's easy to kind of, look at computer models and go like, okay, like the NAM's 10 kilometers, yada, 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 that kind of, or 12 kilometers. It's like kind of hard to kind of break down that scale. And at the end of the day, it's like, you kind of lose sight of the fact of just how small we are and just how powerful these simulations can be, even at the coarse resolutions that we think that they are in our head.
Yeah, I mean, 300 meters is pretty small. If you think about a mile-wide tornado is 1,600 meters across, you can get more than one data point in there. And that's why we were able to resolve the tornado scale vortices, even in that simulation. I think one thing that sort of bugs me about, I love Lee Orff and his work is so inspiring to me. I've watched every one of his talks on YouTube at least once. But he's working in an idealized framework. He's initializing the CM1 model. with homogeneous boundary conditions, no slip surface condition. And that misses a lot of the sort of messiness of the real atmosphere. And so one thing that I'm really curious about is what happens if we push WRF down towards those scales and we can see land surface interactions, we can see storm scale interactions, we can see interactions between the storm and mesoscale features. I mean, one of the tornadoes I got happened right as the supercell was approaching a sea breeze boundary. So, what does that look like at these resolutions? And a real sea breeze band, I mean, as real as could be assimilated by the higher resolution, lower resolution nests. But, I think that's the direction that we got to go to really see, Lee's doing an amazing job of answering how does the storm itself work? And I think that is, those are the kinds of questions that he's answering. I think I'm more interested in, how does the storm interact with its environment? And I think that running these high resolution WRF simulations, or maybe it's some other model, maybe it's MPAS or some FV3 thing. I'm excited to take the UFS for a spin once I can get that up and running. But anyway, something high resolution so you can see how the storms interact with their environments, because I think that is another important piece of the puzzle that maybe hasn't gotten as much attention from a non-idealized modeling perspective.
Yeah, that's something that as an engineer, I noticed these kind of unrealistic initialized conditions that you talk about, and I'm glad you're bringing it up because it's something that I've kind of just had in the back of my head, but not having the meteorological background. I'm coming from an engineering perspective and more of, I understand atmospheric thermodynamics enough and fluid dynamics in my engineering brain, but kind of understanding these initialization factors and kind of how everything's set up seemed a little, like you said, too idealized. So it's really interesting that you're looking at this environmental kind of impact and how, because they are really critical kind of features at the end of the day that we kind of really need to look into. Like, okay, yes, we're looking at a supercell in a computer, great. But we got to add on that next layer and kind of really flush out more answers beyond this idealized case, I guess you could say.
Yeah, I think that's exactly right. Again, I don't want to sort of diminish Lee's groundbreaking work for an instant because
for sure.
Because I think that you got to start somewhere.
Got to walk before you can run.
Yeah, right. But I think that there's we're coming up fast on the sort of limits of our existing parameterizations. So what counts as a subgrid scale process in our current suite of 3 kilometer convective permitting models versus what do we need to parameterize in terms of interactions with forests or interactions with buildings. I mean, could you imagine what a hassle it would be to put buildings into our weather models?
Yeah.
But that's what you got to do if you're going to move down towards the 100-meter scale. You have to put in, do you have to put in cars, highway overpasses? I mean, all this stuff is sort of messing with the atmosphere on some level.
Yeah,
does it
sure.
matter at all when it comes to the evolution of a tornadic supercell? I don't know. But I know Lee is interested in doing that sort of stuff, but obviously, any one of us can only do so much in a given amount of time. So I'm definitely curious to poke around and see how far we can go with our land surface interactions, mesoscale interactions, all that sort of stuff. See what happens. I don't know. Maybe I'll break the model if I haven't already.
Yeah,
that'd be fun.
Yeah, why not? I think it's a super important area to kind of start investing that research into, like you said, because eventually we're going to be running national models at a smaller scale. So these kind of questions are going to have to be answered, especially, take the Northeast, for example, with significant infrastructure influences. I mean, we got cities all over the place, and I imagine that there's going to be a lot of those kind of questions that are going to need to be answered in order to kind of accurately put these models together, however long down the line that we're looking to implement these kind of things.
Yeah, I mean, I heard some, is ECNWF trying to get to 1 kilometer globally by 2025 or 2026? I mean, as long as we keep producing bigger and bigger computers for cheaper and cheaper, there's no limit, really.
Yeah, exactly.
The physics will have to catch up eventually. But yeah, I'm really excited to see what the next round of modeling brings.
Awesome. All right, Jack. I want to kind of wrap things up here. One last final question, I guess, for you is, I know you were out in the high plains during 2021, if I'm not mistaken. What do you look forward to in terms of maybe trying to get back out there? Are there any plans in terms of maybe, since you're seeing to have some investment in mesoscale meteorology now, at least from a computer side of things, are you looking to get back out there again?
Yeah, I got a couple weeks out on the plains planned for right after graduation. I'm going to head out there first with one of my buddies and then with my dad, which is going to be really special. So yeah, we'll see what happens. Hopefully we get some storms, but yeah, June 1st-ish to June 20th-ish, I'll be out there and we'll see what we can see.
Yeah, I'm thinking of I'm still debating if I want to do earlier or later. So I'm
a high plains guy. I can't deal with this 60-mile-an-hour Alabama stuff.
Yeah.
I can't deal with sitting in chaser traffic in Norman, Oklahoma. Give me a Wyoming field with a stationary supercell, and I can put out my lawn chair.
Yeah.
I'm a cranky old man in that regard already.
Yeah, I mean, I was having a lot of fun in northeastern Colorado and the Nebraska Panhandle this year, so it kind of made me want to explore that high plains stuff as much as I loved West Texas. But I'm thinking almost doing that, later typical season push in order to kind of enjoy that high plains scenario. So I hope to cross paths with you out there if that's the case.
That'd be fun.
Heck yeah. Lastly, where can people find you? I know you got a number of areas that you're located at, particularly the socials as well as your forecast blogs.
Yeah, I'm on Twitter mostly at Jack Sillin, Sillin. I sort of reject other social media on principle. I hate the book face and instant scam. Again, I'm slipping into my grumpy old man mode here. If you're interested in forecasts for Western Maine, New Hampshire, they'll be up on forecasterjack.com. That's about it for all of my being online. I'm a Twitter and blog guy only. So
I don't blame you. I spend probably the majority of my time on Twitter as well at this point. I feel like it's the easiest, to kind of get your thoughts out there. And like you said,
it's the easiest to escape these stupid algorithms. I hate the algorithms.
Yeah.
I got tweetdeck.twitter.com. If you don't have that, you should get it right now. It's free so far. Yeah, escape the algorithms. Turn your Twitter feed on the latest tweets only, not whatever their stupid algorithm wants to feed you to make you mad.
Yeah.
So
I love the idea of that.
There's my soapbox.
I think I might have to download that after this because I'm in the same vein of thought. So thanks, Jack, so much for coming on. And it's been a pleasure talking to you. And, maybe down the line I'll have you back on to maybe talk some more interesting weather. It's always seems like we always got something to talk about these days. So once again, thank you very much.
Thanks so much for having me.